I remember the first chemistry class I took in college. It was in one of those big auditorium-type classrooms. The professor comes in, and the first thing he said was to close your eyes. Think about somebody you admire. They can be alive, they can be dead, but they have to be a real person. It can't be a fictional character, a relative, or a person from history. Just think of that person right now as you listen to me. Now take in a deep, slow breath and hold it. As you hold it, I want you to realize that there is a very high probability, very close to 100%, that at least some of the molecules that make up the air in your lungs were also in the lungs at one time of that person you are now thinking of. Hold that thought, hold that realization, hold that memory of that person while you slowly let out that breath. A long time ago I lived in Taiwan, and one of the ladies in the office where I worked heard that I liked to drink coffee. She gave me this card of a specialty coffee shop downtown and recommended that I go check it out. So a couple weeks later I made my way down there. The place was interesting. It was both a coffee bar, a coffee retail shop where they sold many different types of coffee equipment, but they also had all kinds of classes on the weekends about coffee, how to make it, how to grind it, how to grow it, the history of it, and everything else. I was sitting at the bar, and the girl behind the bar was boiling this huge pot of extremely strong smelling coffee. It was really, really thick. I couldn't imagine what she was doing, so I asked, and she explained that she was creating the base for many of their custom-made iced coffee drinks. They made the strong, pure coffee, and then they would mix it with whatever other stuff they would mix it with, and then sell it throughout the week. They sold a ton of different types of coffee-making equipment to make coffee in plenty of different ways. One of the biggest reasons for confusion in human thinking is our misunderstanding of cause and effect. We seem to have this cause-effect generator in our brains. Supposedly it helped us survive a long, long time ago when life on Earth was much more difficult than it is now. I guess having a very fast but inaccurate brain was much better than having a slow but accurate brain. From a purely structural standpoint, one way to create ultra-fast decisions is to assume plenty of linkages between two things that aren't linked at all. They have seen this in kids as young as 6 months. They put a kid in front of a screen with two blips moving around. The two blips are each driven by separate programs that operate independently. When both blips are moving, the kid seems happy as if everything is functioning normally. When both blips stop, the kid seems happy as if everything is functioning normally. But when one blip stops and the other keeps bouncing around the screen, the poor kid looks extremely upset, as if the universe just broke. They've done many other similar experiments and believe that we have some kind of instinctive wiring inside of our brain that makes us connect things and believe they are connected when they really aren't. One of the most common representations of this is called post hoc ergo propter hoc, which essentially means after this, therefore because of this, which means if we see two things in sequence, A and then B, we'll assume that B is because of A. But it turns out this assumption is embedded more deeply in our language and our thinking than we realize. For example, if we don't understand why something works, simply by describing how it works in two different ways gives us the illusion of knowing why. If we describe it one way and then describe it another way, we think the first way is because of the second way. For example, consider these two statements. 1. I drop my keys and they fall to the ground. 2. Two objects are attracted to each other according to the law of gravity. Both essentially describe the same thing. One is just a common way of explaining normal everyday things we are used to seeing. The second is a more complex, more specific mathematical way of describing the same thing. But it seems completely rational to say my keys fall to the ground because of gravity, when in reality that's like saying my keys fall to the ground because they fall to the ground, or gravity exists because gravity exists. Coffee is interesting in a way that alcohol is interesting. There is a huge coffee industry and has been ever since it was discovered. Despite all the different ways there are to make coffee, the process is essentially the same. Take a coffee bean, dry it out, cook it, crush it up, and get the stuff in the crushed up coffee bean into some hot water somehow and drink it. Would the entire coffee industry exist if coffee didn't contain caffeine? The reason he had us go through the exercise in the beginning of the chemistry class was to start to get an appreciation for very large numbers. Our human brains are not intuitively designed to understand large numbers. Even though we say things like billions and trillions, we don't really appreciate what those numbers really mean. And in order to fully wrap your mind around scientific concepts in a way that you can actually use them, think about them, and hopefully combine them in potentially new ways, you have to take time to develop an intuitive understanding of large numbers. For example, we all know the speed of light is very, very fast, and most of us know that it takes about 8 minutes for light to get from the sun to where we are. But having an appreciation for just how far away the sun is takes some getting used to, even though the sun is always there, and without it, no life at all would exist.